in today's note, we are going to look at displaying data. So there's just some terminology we want to get into because the type of data we look at will determine how we want to display it. So one type of data is categorical data, and this is data that are types rather than numbers. So an example for something like this might be like your favorite color. So you could look for colors, types of snacks, or sports teams. Basically, the data that you're looking at are types rather than actual specific values. Continuous data is data that can have any numerical value within a finite or infinite interval. So this is basically, if you were measuring it, there could be an infinite possible or infinite possibilities in terms of what that value could be. So an example might be heights. Right? Heights would be continuous data, because if you're measuring someone's height, you could break it down to the centimeter, to the millimeter, to the micrometer, and so on. And it could be any value in between that, right? It's just not going to be clear cut. You are 6 feet 3 inches, right? Or you're not just a clear 180 centimeters. It could be 181, 182, 182.5, 182.05, something like that. You could also look at weights or mass. You could also look at time. So basically almost anything that you're measuring, right, if you're actually physically measuring, that would be something that's continuous. And discrete data is data that is distinct or can be counted. So this could be like, say, number of students who like sushi, right? You can count that. Or it could be how many siblings do you have, right? It's distinct. There is a specific number. You're not going to have half a sibling, or a quarter, or a third, or something like that. It's just going to be 1, 2, 3, 4. So those are distinct numbers. Bar graphs and circle graphs are the first type that we're going to look at, and these are used to display data that you can count. So these are going to be used to display discrete data. So John has a job at a music store, and the table shows John's expenses last month. So we're going to create a bar graph to represent the data. And this is going to be, again, discrete data because it's going to be distinct or counted, or can be counted, so it's specific. Right? It doesn't have a finite or infinite interval. So again, the way we start off with our bar graph, we're going to create a title. So John's monthly expenses. The one column with the categories is going to be along the bottom. So our expenses are going to be on the bottom. And the dollar amount is going to be on the side. And this is typical of a table, right? The first column is usually your x-axis. The bottom column is usually, or the second column is usually your y. So we're going to need to come up with a scale for this graph. The best option is probably going up by 25s. So we'll start at 0, 25, 50, 75, 100. I'm just going to skip. So my squares are still going up by 25. I'm just spacing it out because it might be a little too crowded, but I'm still going up by 25. See if it helps take out those. So each square is still 25. So the first column is entertainment, so we'll put E, and John spends $100 on entertainment. So I'm going to put a bar up to 100. Choose to color it in if you wish. And then I'm going to move on to the next one. So clothing, we'll just leave it as C, is 225. So I'm going to put a bar up to 225. The key thing about the bar graph is make sure there are spaces in between each bar, because it shows that they're separate. Right? These values are separate, these things are separate. So we have our clothing bar. The next one is cell phone, so we'll use CP, is $50. Again, make sure you leave a space. Then we have lunch, or L, which was 75. Transportation is 80. So this one we may have to just estimate a little bit for 80. We know it has to be slightly above that third line. And that third line was 75. So again, it doesn't have to be quite exact, but as close as we can get. And then finally, our last one is rent, which was 150. And here is our bar graph. So there's our bar graph. We have the bars representing the discrete data. They are separated with spaces in between. And a couple things we want to keep in mind, right? There should be a space. Let me just move this up. Should be a space in between bars. And each column should be the same width. So they're all one bar wide, and so all of them should be the same. If you decide to make them two, they all need to be two, or so on. The next thing we're going to look at is the same data, but we're going to look at creating it or making it into a pie graph or a pie chart. And what we're going to have to do is we're going to have to basically turn this into angles. So we need to know what percentage each represents and what angle that will represent. So for entertainment, again, just going back to that chart from above, there's 100. Clothing was 225, cell phone was 50, lunch was 75, transportation was 80, and rent was 150. We are going to need to keep track of totals. So the total amount of money spent is 680, because that's going to help us with the percent. So to find the percent of each one, we know that entertainment is $100 out of a total of 680, multiplied by 100. So we divide what we have by our total, multiplied by 100, and we get roughly 15%. We continue that with the rest of them. Take our amount, divide it by the total, multiply by 100 to get your percent. $75 divided by 680 multiplied by 100 equals roughly 11%. Again, simple calculations, just making sure we do them correctly and our things are in the right step. And again, if we want to double check all those percents when we go through and add them up, should equal 100%. In the last part, we need to figure out what angle each section is going to cover, because that will help us draw our graph. So in order to do that, we need to take the decimal version of our percent and multiply it by 360. Right? We want to find what is 15% of 360. We get 54 degrees, right? Because there's 360 degrees in total in a circle. So 0.33 times 360, 0.07 times 360, 0.11 times 360, and again we're taking approximates here, right? There may be some decimals, but we're just rounding everything. 1, 2, and finally the last one, 79 degrees, and when we do the totals, we should get 360 degrees. One thing to note, just as a side, sometimes rounding will give values or will give totals other than 100% and 360 degrees. So depending on how you round, you may have values that are slightly above 100, slightly below, or slightly above 360, slightly below. As long as they're very close, then it's fine, and you should realize or recognize that it's just a rounding error. So what we're going to do now is we are going to use those measurements to come up with what our pie chart will look like. We're going to still put a title, so I'm just going to put it at the bottom here just because I don't have any room at the top. So John's monthly expenses. And what you're going to do, or how you're going to start this, is hopefully you have a protractor. Again, you could also enter all this information into Excel and or Google Sheets and come up with and get it to spit out for you, but it is helpful to know what or how these numbers come about. So we're going to draw a line to a center, and we're going to then figure out, basically using a protractor, what each measurement is, or what each angle measurement is. So I'm just going to start, again, I'm going to roughly show what it's going to look like. I don't have a protractor on here, but I'm going to roughly draw them out as to what they should be. So this will be our clothing, and let's actually go back. So clothing was all in green. Keep things color coordinated. So clothing was in green, and we're going to label what it is. So clothing and $225. Entertainment was red. And if I roughly draw out 54 degrees, it looks something like that. So measuring from these two angles, we get 54 degrees. And that was entertainment. Or $100. Our cell phone was light blue. So again, that I'll put over here. Again, where you put them isn't really too much of a big deal, as long as you're getting your angles correct. So the cell phone, or $50. Lunch in orange. Slightly bigger than that. We have our lunch, or $75. Transportation was in purple. And roughly 40 degrees. And that was $80 for transportation. And then whatever's left over will be our last one, which we did in the yellow. So the last one would be our rent, or $150. So again, roughly that is what our bar graph or our pie chart circle graph will look like for John's expenses, and we've seen what it looks like as a bar graph. So just different ways of representing that discrete data. The other way, or another way that we can look at it, is histograms. And histograms are used to represent numerical data, or basically or continuous data. So histograms are used to represent continuous data. So we are looking at something that has infinite or finite intervals, or basically something that we can measure. So William measured the heights of students in his math class. The heights are rounded to the nearest centimeter. So even though we rounded them, we see whole numbers. We know that height is a measurement. It could have an infinite number of possibilities. So even though these don't look like that, just keep that in mind. Height can have any numerical value, which I just mentioned, so this is continuous data. And some of the rules that we have to do when we're looking at histograms is, because it can have any numerical value, we have to create intervals. Or basically, we're going to create a range of values that our data can fall into. And there are some kind of rules that go into play. And hopefully as we go through the example, you see what I mean by intervals. So first, any histogram should have between 5 and 20 intervals. And in other words, we're going to have between 5 and 20 bars on our graph. To determine the length of each interval, find the range, which is the highest to lowest. So I'm going to find the range of my data. If I go through, I can find that the highest value is 94, the lowest value is 130, so the range is equal to 194 minus 130, which equals 64. So I found my range for the first part, or the second rule. Then what I want to do is determine the interval length, so how big each bar is going to represent, or how big my intervals are going to be, by dividing that range by both 5 and 20. So if I do 64 divided by 5, I get 12.8. If I do 64 divided by 20, I get 3.2. So that means that the length of my intervals should be between 3.2 and 12.8. So length should be between 3.2 and 12.8. So what we're going to choose, basically we want to pick a nice number in between that to help make it easier to count by. So I'm going to pick or choose my interval length to be 10. 10 is a nice easy number to count by. And then the final rule, there should be no separations between the bar. So what we're doing is we are going to start out with our interval. So our first number, or our starting number, is going to be our lowest one. So 130 is our lowest, and it's going to go to up by 10, or 140. And I am going to use a round bracket here at the end and a square bracket at the front. So one thing to note, square bracket includes the number, round bracket does not include the number. So basically what this means, or what this interval is representing, is I am taking every data value that I have between 130 and 139. But I am representing as 40 for that interval length. And just because we don't want to include values that are in both intervals. So it's just a way to help avoid that. So what we're going to do, let's continue with our intervals so that we get those done before we start figuring out everything else. So we continue on from that. So the next one will include 140, and we go to 150, but with a round bracket because we're not going to include 150. So it's actually going to be 140 to 149. Then we go, our next interval is still going up by the 10, so 150 to 160. But because we have that square and round bracket, we're actually counting 150 to 159 to prevent any overlap. 160 to 170. And again in black, I'm just going to write down what values we're actually counting. $170 to $180. $180 to $190. And then lastly, $190 to $200. Now you would keep going with your intervals until you reached or gone past your highest value. So in this case, our highest value is 94, which will be included in that last interval, so we don't have to worry about going any further. If we had values above 194 up into the 200s, we would have to keep going with our intervals of 10. So once we have our intervals set out, now we need to tally. And what we're going to do is we're basically going to go through our data, so these points up here or these values up here, and see how many are between 130 and 139. And when we go through and count, we should find that there are 4. So all we're going to do is just tally 4 to help us, and then the frequency is just putting it into actual numbers. Same thing for the next one, so anything between 140 and 150, keep in mind we're actually counting 140 to 149. And the next one, 150 to 159, there should be 5. 160 to 169, there should also be 5. So again, going through, count those numbers, see how many are in this interval. I've just done this before, so I just know quickly what they are, because I don't think you would want to sit there and watch me go through and cross them off. But again, I'm just going through my values at the top, and I'm seeing which ones fall into these specific intervals. And lastly, there are 2. So what we're doing now that we have our frequency, we have our intervals, so now we can start to set up our bars, right? We are going to look at student height. So student height is going to be our title. Our frequency is going to be on the vertical column, so our frequency, and our interval or height is going to be on the bottom. So we can see that our interval doesn't start until 130. So what we can do is we can use a basically we can use a break to basically show that we're skipping from 0, right, because it's always 0 and the 1, and we're going to jump up to 100. So that means 110. Actually, I'm going to skip all, so 120, 30, 140, 50, 160, 80, 200. So basically that little break indicates that we are skipping everything between 0 and 100, and the reason is because we know that based on our intervals we don't have any values that are before that. We do want to leave some space between the start and the first interval, so that's why we started at 100. So what we're going, going up, we'll go up, each square will be 1, but I'll scale it off and write in 2s just to again save some room, keep it fairly neat. So what we're going to do now, our first interval is from 130 to 140. So that is from here to here, and we have 4. So we're going to put a bar that goes from 130 to 140. Our next interval is from 140 to 150, and it's 2. So that's going to go here. Right. And the thing about histograms is that there is no space in between the bars. And you can argue that this is because the data is continuous. So it's kind of an interval or a range. There's no separation between them. Our next one, 150 to 160, there are 5. And again, just going through. Our frequency tells us how high it's going. 160 to 170 is 5 again. Again, just making that bar. 170 to 180 is 7. Again, we do want to keep the bars the same width. Well, that and because our intervals help us keep that width consistent, because they're always going to be 10. And we have our measurements or a scale along the bottom to help us with that as well. 180 to 190 is 3. And finally, 190 to 200 is 2. So we have our histogram. The last thing we can do, I'll actually use it in red just so we can see it. We can put the numbers in each column or the frequency above each section just to help us if we were to go back and look. And that is how you come up with a histogram. So again, hopefully from this note you've seen the different types of ways of displaying data, and you know how given different data sets you can then create your own displays.